Hey, this is Mr. Beckstrom, and today I'm going to go over a problem from section 3.8. This is on implicit differentiation, and when I usually teach this section, I kind of explain it this way. So with implicit differentiation, a lot of times when we're solving equations and we're differentiating, we solve for y, and then we just differentiate. And everything on the right hand side of the equality is x's, and we just go ahead and differentiate with respect to x to everything, and we get this nice answer. Well, in some cases, we have these equations where it's not really easy to solve for y, but we need some kind of method in order to do it, in order to find uh, the derivative of y with respect to x. And so it's really, we're doing the same kind of process, except that we're doing it with equations where we haven't actually solved for y yet. So, so we have a process for that, and it's really the same process, except for the only difference is that every time we get to a term that has a y in it, we have to add a dy, basically a derivative of y there. And I'll show you what I mean. Or I usually put a y prime, but you can kind of put whichever symbol you want there. I think the book uses dy over dx every time. They're taking the derivative of a y instead of an x, and that's fine too. I mean, you're going to end up getting the same general solution at the end. But let me show you what I mean here. So here's our equation. It's the sine of 4y squared minus 8x is equal to 9e to the y, and we want to solve for dy over dx, which is just basically the derivative of y with respect to x of this equation. So let's go ahead and do it just like we normally would take the derivative of anything, but except that whenever I take a derivative of something that's not an x, basically in this case a y, I'm going to add a y prime. I'm just going to add a little y, add a little y prime, just like this, y prime. And then that's what I'm going to end up solving for at the end. Like I said, I think the book just adds the whole dy over dx, but I like to shorthand. All right, so first things first. We have to use the chain rule for this. So to use the chain rule, the derivative of sine is cosine. So this would be cosine of 4y squared times the derivative of the inside function here, because we got to chain rule that. And the derivative of 4y squared would be 8y. Put that out front here, that's fine. 8y. And then, because I just took the derivative of a y, I'm going to go ahead and add a y prime there. I'm going to go ahead and add a y prime there. Only when I take the derivative of a y. Now, minus 8x, just using the power rule, becomes an 8. And that's going to be equal to 9 e to the y. Well, e to the y is what? Well, it's e to the anything is just that thing times the derivative of that thing, right? So that's just e to the y times the derivative of y. Oh, which derivative of y is just 1, right? So times 1, but I did take the derivative of the y, so since I took the derivative of the y, I have to also multiply by a y prime. All right, so this here is what I get when I take the derivative of each term. And every time I specifically took the derivative of a y, I had multiplied by a y prime. Now, why did I do that? I did that because I want my final answer to be y prime is equal to something, right? Yeah. So now my next step here is I want all my terms with y prime on one side. Okay, so I'm going to take this term, I'm going to leave it over here. So 8y cosine of 4y squared times y prime. I'm going to bring this one, it has a y prime, so I'm going to do minus 9y, oh, left something out there, e to the y prime, and that's going to equal, I'm going to take that 8 and bring it over here because it has no y prime. I don't need it. All right, now why are my terms with only y primes on one side and the terms without the y primes on the other? Hopefully it brings up some memories, but if it doesn't, it's because I want to factor it out. So y prime factored out, and I'm just left with here, I'm just left with 8y cosine of 4y squared, right, minus 9e to the y. I factored that out, is equal to 8. And now I can divide both sides by that. So finally, y prime is equal to 8 all over that big old gigantic mess. 8y times the cosine of 4y squared minus 9e raised to the y. And that should be it. If you have any questions, let me know. A lot of these are done really the same process. Go through, take the derivative of everything. Every time you take the derivative of a y, you multiply by that term by a y prime. You gather y primes on one side, everything without a y prime on the other. You factor your y prime out. You divide both sides to solve for the y prime. All right. If you have any questions, let me know. And I hope you have a great rest of your week. Thanks.